What's up everybody? So in this video we're going to continue and do some more questions on the topic 9.1. So this is basically everything to do with the xylem, okay? And we can see I'm only taking real past paper questions. These are not questions I'm making up. You can see this was question 39 on one of the real past papers. Your teachers will most likely use these exact questions, okay? They won't make up their own questions. So the more of these you do, the better you will be ready for this test. So let's just get to it. Again, try these questions by yourself first always. So what is a role of xylem? Okay, so xylem, if we look at a plant, is one of the pipes inside the stem and the roots, okay? And the xylem is a little pipe that has one main job, and its job is to take water from the roots. So basically, water will go into the roots. Now, the xylem is this pipe here, and it will take this water and transport it all the way from the roots to the top of the plant, such as the leaf and the stem up here, to provide it with minerals and water. So it moves both minerals and water from the bottom to the top, basically, okay? So could it be A, it absorbs minerals from the soil by active transport? So this thing is saying that the xylem absorbs minerals from the soil into the root, but this is not true. The xylem moves water and minerals from the root upwards, not from the soil into the root. That's something else, okay? The xylem only moves things from the root upwards, not from the soil into the root. So it cannot be A. B, it translocates amino acids from source to sink. This is not the job of the xylem. This is the job of the phloem. Maybe you haven't learned about the phloem, but you'll learn about this in 9.2, so the next subchapter, okay? Because the phloem will take things from the source. You can call you'll see when we get to 9.2, because that's a whole another thing. You just need to know that B is rather the phloem, the other pipe involved in the stem, because there are two main pipes, the xylem and the phloem. And the phloem does this part, okay? Now C, it carries glucose to the leaves. This is basically the same thing that B is saying, okay? So this one is also done by the phloem, not by the xylem. So both B and C are done by the phloem. And A is not done by either. Now D, so it's got to be D automatically, okay? It's going to be D. It contributes to plant support with lignified walls. Okay, so we know that the xylem is this pipe inside the stem. This pipe is pretty strong, so it can contribute to support. And in other words, strength. It can make the stem a bit stronger, okay, by having lignin in it. The xylem is made up of lignin. Lignin is a little material that makes the xylem strong so that when it sucks up water, it doesn't collapse, right? So we know if we use a paper straw, which is really weak, as we suck water up, the wall will collapse, okay? The straw will start collapsing, okay? But if we use a plastic straw, that's a stronger material. Then if we suck up water, the straw will stay strong and not break. So that's the whole point here. It contributes to plant support with lignified walls. So it's got to be D. And again, if you don't understand what I'm talking about in these question videos, make sure to check out the teaching videos first, because I have made a teaching video on all this stuff already. Okay, which plant hormone causes the stomata to close? Okay, so basically, to understand this question, you need to know this. The xylem brings up water, as we just said, right? And it brings it to the leaves. Now, the leaves will use this water and this nutrients to survive, but it will also expel some of this water. It's the same as sweating. Although we drink water, we're not going to keep all that water. We sweat, right, to get rid of some water. So it's the same in plants. Now, this extra water will leave through something called stomata. Okay, here I have an image. So if we zoom in real close, we'll see a bunch of these structures, okay? And these are called stomata, basically like a sweat gland. And it can be closed like this, so now it's closed, or it can be open, okay, open. So right now it's open, there's a hole. This called the stomata, and water can leave through this hole called the stomata, okay? And this is basically sweating. So they're saying which plant hormone causes this stomata to be closed rather than open. This is something you need to memorize, and it's called abscisic acid, okay? So there's this small molecule that when it's present, so for example, when it's released onto the leaves by the plant, it will cause this thing to close, okay? To prevent sweating or prevent transpiration. Okay, it's called abscisic acid. There are so many questions on this type of molecule. You'll see as we keep going. Now, why not auxin? So we know auxin is basically a molecule that is involved in plant growth. It makes sure that the plant grows towards light. Gibberellin is a molecule that is related to germination. Okay, it's a molecule that is released to allow a seed to germinate. This you'll learn about later if you haven't learned it yet. Same with auxin. And phytochrome is basically involved in photosynthesis. Okay, it's a molecule involved in photosynthesis. So if you knew about abscisic acid, you wouldn't even have to care about what these are because you'd know it's D automatically. Okay, cool. Next one. This is going to be a trickier question, but let's see if you can do it. The diagram shows a cross section of a leaf. So basically, if we take a leaf, right? Imagine you take a leaf and you look from the side, right? The thin side. You can see how thin a leaf is, right? So they're basically showing you the leaf from the side, okay? So up here would be the top of the leaf, and this would be down here would be the bottom of the leaf, okay? And you can see that if we were able to look really closely with a microscope, we'd see the leaf is made of stuff like this from the side. Now, normally at the bottom of the leaf, so let's go back to this leaf. So let's say we're looking here at the bottom, okay? Because we're basically looking at this image is pretty much looking at, we're zooming in here. We're looking at this side right here of the leaf, this side. Okay, so it's really, really thin. Now, normally, as you can see here at the bottom of the leaf, there are some small holes. These small holes are the stomata, okay, these holes, okay? These holes are surrounded by cells. This is a cell right here, and this is another cell, okay? And when they start, they can take a certain shape that allows the hole to open. Okay, so if we look here, we can see this hole, and we can see these cells. These cells right here, now this Y, the cell, is basically this cell here, this one here, these two cells. When they take up a certain shape, a hole will start showing. So they're asking us, and normally all of these stomata are at the bottom of the leaf, not the top. They're mostly at the bottom. They can be on the top of the leaf, but they're mostly located on the bottom of the leaf. That's why we're seeing here at the bottom. Now, they're asking you what X and Y are. So Y causes X to open, allowing water to exit the leaf when water is scarce. So they're saying this cell allows this thing to open. That's true. So far it's true. We know that when these cells take this shape, they allow this stomata to open, allowing water to leave. But their reason is wrong. They're saying when water is scarce. When water is scarce, the plant would want to conserve water and not allow it to leave. So the logic here is right, but the reasoning is wrong. The reasoning is wrong. This would not open when water is scarce. When water is scarce, it would close to conserve water inside the plant to allow it to survive longer, okay? So if this word was plentiful or abundant, then it'd be right, but it's saying scarce. So could it be B? Y responds to abscisic acid by closing X to prevent water loss. This sounds right. So I told you that abscisic acid can, when it's present on the leaf, it will cause these stomata to close, right, to prevent water loss. So how does it do that? It stimulates these cells to take up this shape and thereby closing the hole. So Y, this cell, responds to this acid and then it closes, and therefore the hole will close, which is X, and this will prevent water loss. So that's true. It's got to be B. Okay, Y responds to gibberellin. No, again, gibberellin is a hormone involved in seed germination. So this is not related to the leaf itself. So this would be wrong just because this hormone is not related. Okay, Y causes X to close to increase transpiration. So we know transpiration means sweating or water loss. So they're saying Y causes X to close, and when it's closed, it causes more transpiration. That's wrong, because sweating happens when this hole is open. So when this hole is closed, transpiration will happen less, not increase. So it's not D, it's got to be B. Okay, under which conditions would the rate of transpiration be the greatest? So again, we know transpiration is just the plant way of saying sweat. So what conditions here would have the greatest amount of sweat? What would lead to the greatest amount of sweat? So here I have a diagram, and we can see here is a stomata. Here's the stomata, and there's water, and it can leave. Okay, and we can see that all of these conditions here on this side increase increase the amount of transpiration. You can see more water is leaving. And all of these conditions here cause, let me move this arrow a bit, cause slightly less transpiration. Okay, so this is a pretty good summary. So this is temperature, this is humidity, this is wind. Okay, so let's see. A, humid and cool with wind. Okay, humid and cool with wind. So humid, this means high humidity. Cool with wind. So no, that would cause humidity and coolness would cause less transpiration. So it's not A. Dry and hot with wind. So dry, meaning low humidity. That's all they mean by low humidity. Humidity means how wet the air is, basically. So dry, hot, and wind. All of these cause more transpiration. So it's going to be B. Again, if you don't understand the logic behind this, you need to watch my video. I explain it very clearly and everything like that there. So this is just for questions. Dry, so we know it's B, but let's confirm the other ones. Dry, hot with no wind. No wind favors, no wind favors less transpiration. Okay, humid and cool with no wind. Again, cool and no wind no wind favors less transpiration. Okay, so the answer is B here. Okay, I think we have one more question, so let's get to it. One more one. Oh, you're gonna like this one. Which hormone is involved in closing of the stomata? Look how similar this question was to the other one we did. Which hormone is involved in the closing of stomata? Look at the other one. What plant hormone causes stomata to close? It is so similarly phrased, right? It's crazy. So you need to know this. This is something so cool to notice. The questions repeat so much over exams. If you do enough questions, you would have seen every kind of question, and all they can do is rephrase the question in a different way, but the answer is still the same. So you'll notice questions will repeat and repeat over exams. So if you do enough questions, you will guarantee yourself a good test, okay? Just do many, many questions. This is my biggest advice for anybody doing IB. The more questions, the more favored you are, but you gotta do IB questions. Get used to what they ask. So we know it's gonna be what? Abscisic acid, right? We know it's that one, because auxin, again, is related to the plant growth towards the sun. This one is related to germination of the seed, and this one is related to some other process related to plant growth, okay? So you know it's A. So in the next video, I'll be covering some more multiple choice questions. The more you can do, the better. Just keep going and you'll see. They repeat and repeat and repeat.